Hello everyone, hope you all are doing well. So in this video, we'll discuss the of Leetcode BiWeekly contest 109. It's a medium level problem. The problem name is ways to express an integer as sum of powers, right? We'll go to the solution, but it's a typical, recursion plus memoization based problem. We'll see how, okay? So the problem says that given two positive integers n and x, right? Return the number of ways n can be expressed as sum of xth power of unique positive integers. In other words, the number of sets of unique integers n1, n2, nk where n equals to n1 raised to x plus n2 raised to x plus nk raised to x. Don't worry, it's a complex equation. I'll come to the simplified version of it, okay? Now, since the result can be very large, return it modulo 10 raised to power 9 plus 7. For example, if n is equals to 160 and x equals to 3, one way to express it is this. 2 raised to 3, 3 raised to 3, 5 raised to 3, right? Forget about the problem, right? It says that this is a number you have and this is a power you have, right? Now, this number 10 can be expressed as something like this. A number power x plus another number power x plus another number power x, right? In this case, I'm assuming, suppose there are three numbers whose same power. Just see, this power is given, right? When you raise those numbers to xth power and you add them, you get this number, right? Simple. This is what we have to do. Now, this is one combination, n1, n2, n3. There could be other combinations as well. Remember, in all the combinations, the number of variables can vary. I mean, here we have three numbers. It could be 2, it could be 4, it can be fine, any numbers. But the powers will be same. Getting it? The powers will be same. So this is what it says. I have to find the number of combination or number of sets which satisfy this equation. That whatever is the count of those numbers, if I raise those numbers to xth power and add them, I get the given number. Simple. Like n equals to 10 and x equals to 2. What I can do, 10 can be expressed at, also remember n1, n2, n3, all of them, they have to be unique, right? Power of unique positive integers. So the power is 2. I can make 3 raised to 2 and 1 raised to 2. This is the only possible combination you can make. This is 9 plus 1 and hence you get 10. Let's come to 4. Remember, all the numbers that you should have on the right hand side, or rather which basically add up to give you n, should have a power of 1, right? X equals to 1. So 4 can be expressed at 4 raised to 1. Great. 4 can also be expressed at 3 raised to 1 plus 1 raised to 1, and hence there are two combinations. So answer is 2. This is what the problem is asking us to do. Obviously, the number of these sets can be very large. So we have to take modulo with 10 raised to power 9 plus 7, right? So just see the number that I have, right, is 300 and the power is 5, right? So very small constraints, right? No need to worry. But obviously, you just can't write the brute force approach without any optimization because that will time out, right? So just see, whatever is the problem saying, whatever the problem is asking you to do now, just write the code for that one. Now, how to write the code? Simple. I have to form n, right? I have to form n. Now, this n can be expressed at xth power of many numbers. I don't know what numbers, but many numbers, right? Let's start with 1. That means let's do one thing. Suppose here, I'll take this case, right? Suppose I have to find the answer for 10 and power is 2, right? So what I do, suppose, so the first number I start with is 1. What are the options? I include 1, I exclude 1. If I include 1, what will happen? I started with number 10 minus 1 raised to x, that is 1 raised to 2, 9. So if I include 1, I have to find the answer for 9. That how can I form 9? But now when I have to find the answer for 9, right? When I have to find the answer for 9, remember, I have to consider the numbers from 2 because 1 I have already considered. Simple, right? If you consider 1, you have to now find the same answer but for 9. That how many sets are there where I can express 9 as sum of xth power of some numbers, right? What's the other option? The other option is do not include 1. In that case, since you're not including 1, now you start with 2. I mean, now see that from 2, can I raise the numbers to xth power so that some of the numbers add up to give you 10, right? What I mean to say, you start with 10. If you include 1, this is gone, you have to find the answer for 9. If you do not include 1, you have to find the answer for 10 only. But here you start with 2, here also we start with 2. Getting it? That is what we have to do. So I'll show you a code and then we'll go into in depth how to work with these codes, right? But exactly do the same thing what the problem asking us to do. I've made a function count ways helper. This is n, the number I want to form, this is the power, this is 1. 1 means I'll start with 1, right? I have to find the numbers, right? Whom I'll raise, whom I'll assign the powers, right? So I'll start with 1. I have unique positive numbers. So that is why, obviously, unique positive numbers mean you start with 1, then 2, then 3, 1 raised to x, 2 raised to x, 3 raised to x, and so on. I'll have to check all the possibilities. And this basically to take care of avoiding the recalculations, right? So let's first go into this function. Okay, forget about this, forget about this, forget about this, right? Let's come to this. Include the current number in the sum and recursively find ways, right? That's why I've added the comment. So include current is equals to count ways. If I include it, what happens? N minus math dot power of num x. This is the current number I'm considering. So I'll whatever is the number, so it will be num raised to x. Just subtract it, n minus num raised to x. This is the new number for which you have to find the answer. Also, power will remain same. Now, if you have consumed num, check for nums plus 1. That means if you have raised 2 raised to x, forget about whether you have included it or not. In this case, I'm including it. Now you have to check for 3 raised to x. So now the next number you have to check is nums plus 1. And this is the hash map I'm passing, right? Simple. Include current mod. This is just to avoid the overflow. So this is how I include it. Now how I exclude it? Exclude the current number from the sum and recursively find way. So n will be same because I am not including the current number. So n will be same because I'm not subtracting the xth power of the current number. So n same, x same, but nums plus 1 because 2 raised to x, suppose I'm considering num as 2. So 2 raised to x, here you have considered, here you have avoided. So forget about this, whether you have considered or avoided it. Now you have to consider 3 raised to x, right? That is what I have done here. Nums plus 1 and memo. Done. These are the two things I wanted to do. Now, edge cases I'll take care, but this is the core logic. What are the total number of ways? This plus this plus this. Take the mod to avoid overflow. And this is, you put that in hash map so that if someone asks you the answer for the same, you do not recalculate it, you just return it, right? Now let's come to the base conditions, right? If n is equals to 0, right? That means I have formed all the numbers that I wanted. I just return 1. There is only one way to do this, right? There is only one way to do this. Getting it? So that's what I do. If n is less than 0 or math dot power of nums of s is greater than 1, is greater than n. That means now there is no use of considering the further numbers. If num power x is greater than n, then obviously nums plus 1 power x will be greater than n. Forget about this. No ways we can form the number. Also, if nums is less than 0, then also there is no way to form the number, right? Why nums of 0 equals to return 1? Because if nums is equals to 0, that means by whatever recursive path I am coming, doesn't matter what is the set, but ultimately I'm getting nums as 0. That was my target. Getting nums as 0 means I started with a positive number and I added n1 raised to x plus n2 raised to x something, and ultimately the final number for which I had to find the answer was 0. That means you have consumed all the numbers, right? What is this n? This is n is the remaining number for which you have to find the answer, right? So that is why you return 1. Here it is 0. Now what is this? Generate a key, right? This is the number for which you have to find the answer. And what if I consider this? These are the two things that are changing, right, my friends? You just have to consider. So how do you memorize, right? X is not changing. What is changing in every recursive call? N is changing. Num is changing. So that means our answer is dependent on these two variables. So n and num. You can create an array also. That will also work, right? That's not an issue because n is a small value, num is a small value. But to take care of that as well, I've just taken a hash map, right? So memo dot contains, if it contains this key, just return it, or else do all this computation and also before returning just save it, right? To avoid recalculation and return the total number of ways. So this is what we do. Again, I'll reiterate, whenever you get these type of problems, right, write the core logic. What happens when I include, what happens when I exclude, and this is my final answer. Now, what are the base conditions? When do I stop? When do I return 1? When n equals to 0. When do I return 0? Or when should I stop the recursive call? When should I prune the tree? These conditions, and just store the answer. That's it. This is what you call a recursion plus memoization, a different form of dynamic programming approach, right? So yeah, I hope you learned something new from this video. Do support it by giving a thumbs up. Do subscribe to the channel as well. In case you have any issues related to this question or solution, let me know in the comment section. I'll revert on each one of them. Thank you. Take care. Bye bye.